Good morning and good afternoon. It's noon Eastern, so we'll go ahead and get started. Welcome to ARA's Webinar Wednesday. I'm Sri Rao, your moderator for today's webinar, ADA Ramp and Sidewalk Inspections and the new ADA Ramp Serviceability Index. Now I would like to introduce you to our presenter, our speaker, my colleague and friend, Dr. Philip Donovan. Dr. Donovan is a licensed civil engineer with more than 29 years of experience in civil and pavement engineering. He's retired from the U.S. Air Force, and he was a civil engineer for his entire military career, working project design, construction, and management around the world. His final Air Force assignment was teaching geotechnical and pavement engineering at the U.S. Air Force Academy. He has substantial experience in non-destructive testing, NDT, particularly with the use of falling weight deflectometer, FWD, and heavyweight deflectometer, HWD. And he also has extensive knowledge in pavement evaluation and design, pavement and asset management, pavement friction testing, runway friction testing, pavement profiling, and geographic information systems, GIS. Phil, I really appreciate it, and thank you for presenting in today's webinar Wednesday. And now I will hand it over to you.
Thanks for the nice introduction. Just wanted to say I put some pictures on here. I was going through my pictures and I realized that picture in the lower right there is 20 years ago this month. Holy cow, it's been a long time. And so just wanted to throw some pictures up there. I've been around a little bit and know a little bit about pavements. That's what the Air Force sent me to school for. So that's my passion. And then now I've extended that onto ADA ramps and it's really asset management, anything to do with asset management. And so ADA ramps and sidewalks are an asset that need to be managed. So just a quick outline of what I'm going to go through. I'll go through the history of the ADA process, define the ramps, how we measure them, and then how we manage them. And then at the end, I'll talk a little bit about sidewalks. And it's a lot easier to do sidewalk surveys than it is ADA ramps. But I'll talk about that at the end. So when did this all get started? When did ADA ramps come into play? Well, ramps have been around a long time. I mean, if you can go back and see that ramps have been built for people a long time, ever since we've had sidewalks. But the guidelines to actually build the ramps so that they're accessible, and when I say accessible, that means disabled people with either vision or mobility issues can use the ramps and safely traverse the sidewalks, has been around since the 1990 ADA enactment. And just January 17th of this year, the DOT has finally said we're going to enforce these standards, and it's through the Public Right-of-Way Accessibility Guideline, PROAG. And before that, there's been a lot of different setups for doing ADA ramps, what guidance for ADA ramps, and the one that we've used is the standard plans for public works construction. So we're going to talk about those today, but they're very similar to PROAG. In fact, they share the same terminology and the same measurements. Locally, you may have different specifications for ADA ramps. So the biggest thing, though, is that the DOJ, the Department of Justice, has not adapted PROAG yet. So really, there's only local or state enforcement of ADA compliance. But why do we have ADA guidelines? Well, we kind of inherently know why we have the guidelines. It's to make the facilities accessible. And, for anyone with any disability that they can use the sidewalk safely. Of course, everyone benefits by ramps in sidewalks. It's a lot safer for using a stroller. It's a lot safer for little kids on their bikes. So the secondary effect is that all pedestrians are safer due to these ADA ramp guidelines. Now you might ask, how big is the problem? Well, this is how big the problem is. Okay, when you use the PROAG to analyze ADA ramps, and we did this for a city in California, 3.7% of the ramps were 100% ADA compliant. Now that could mean that the ramp is perfect, but there's a little lip. Or the one flare on the side of the ramp is no good. Compliance is compliance. It's a yes or no statement. There's no wiggle room there. And so it's a very large problem, and there's no way you can manage this size of a problem if the federal government said all of your ramps must be compliant. In fact, just a quick calculation, it's about $10,000 per ramp to repair a ramp to ADA standards. Now that could be high in some places, low in some places, but on average between $7,000 and $10,000 to repair that ramps. That means this repair for this city would be in the $60 million range to repair these ramps. Not to mention the amount of time it would take to do that. So it is a very large problem for cities to manage. And so I'm going to try to give some guidance today on how to manage those assets effectively to get essentially the best bang for your buck out of managing those assets. But that being said, what do you do with all those old ramps that are non-compliant according to PROAG? Well, essentially, PROAG does not require automatic reconstruction because they understand the complexity and the enormity of the problem. But if you're going to do an alteration or reconstruction, then you have to make it PROAG compliant. If there is limited accessibility and you can remove that barrier, whether it's a lip, whether it's a pole, whether it's a slope, whatever, and it's readily achievable, then it should be accomplished. And the other one is if the existing ramp is a significant accessibility barrier, generally that also means a significant safety barrier, then you need to reconstruct that ramp. The last thing there is if it's technically infeasible to make a ramp ADA compliant, say it's on a slope on a hill, or there's just no access, there's no space, then you can be granted an exception by the appropriate local, state, or federal agency. So, but you have to apply for that exception. You can't just say, oh, I don't have the space, I'm not going to do it. You have to apply to get that exception for your ADA ramp. So again, the biggest thing there is that you don't have to automatically reconstruct, but if you're going to reconstruct, you have to do it right. So let's talk about the ramp parts, okay? You can see that there's a space at the top of your ramp, a space at the bottom of your ramp that are supposed to be clear for turning a wheelchair. And those are usually 4x4 spaces. They have to be at least 4 foot by 4 foot to safely turn a wheelchair or a stroller without that stroller or wheelchair rolling down the ramp if no one is holding on to it. Then of course you've got the ramp itself. And then you've got these detectable warning areas. Those are for the visually impaired so that they don't walk into the street if they're using a cane to see where they're at. And then you've got these things called flares on the sides. And all of those items have specifications. You've got slopes that are the requirements for these items. And they combine, those slopes combine to provide an accessible ramp for use by the disabled. Okay? And it's not easy to inspect a ramp. There are 9 items on here to inspect for each ramp that you're going to say whether or not it is ADA compliant. You've got your landing at your top. You've got your ramp itself. You've got your flares. And you've got this gutter. If you've ever seen a sharp gutter transition, that's really hard to navigate using a wheelchair or even a small child on a bike. If you have that transition not being smooth, that can be difficult. So there are standards to make that as accessible as possible. And I put down here in the lower right the actual to-scale slopes that you would see on ramps. And you can see 2% is a very, very low slope. And that's meant to be. It's meant to be low so that if you're in a wheelchair or you have a stroller and you let go of it, it's not going to roll. That's the key thing, is that you don't want things rolling around and into the street. And then 10% for the flares, that's a little steep, but it's still relatively shallow enough to get a bike or a stroller or a wheelchair up if you decide to go up that flare instead of going up to the actual landing to turn. How many different types of ramps are out there? Well, SPPWC identifies 13. These are not all of the ramp types. There are lots and lots of ramps because of limitations that can't be built like this. And so it is very, very complicated with how many ramps are out there to inspect and how you inspect them. All of these measurements have to be completed on all of these ramps, and it is very difficult and time consuming to measure all of those aspects of each ramp. So how do we collect that data? So there's 3 different ways we can collect that data. You can do it manually. You can use a tablet, which is kind of semi-manual, and you can use LiDAR, which is automated. And I'm going to go through each one of these and point out the positives and negatives of each. But the way you measure is using a tape measure, simple tape measure, and a digital level. And we made these frames so that our troops in the field wouldn't have to bend over all the time and put this level on the ground to get the measurement. So they have these frames that they can use, and the frames are calibrated with the level every day on a level spot, and they will measure the slopes of the ramp. And technically, you are supposed to take 3 measurements for each one of these items. You're supposed to measure 3 different locations, and it's not an average. It's the worst that is marked down to say whether or not that is ADA compliant. See now why it's so difficult to meet ADA compliance? 1 measurement is out, the whole ramp is non-compliant. So it is difficult to get that ADA compliance. And when we are measuring manually, we're using essentially paper forms. And in California, these are the forms that you would see to measure, to write down the measurements. And the problem is there's 7 pages of data for every single ramp to write things down on. That is a lot of paper. And obviously, just inherently, you understand that managing all of that paper for an entire city of inspections would be almost impossible, if not impossible, to keep everything straight. So what's the next best solution for that? Use a tablet computer where you enter the information into a tablet and it's automatically uploaded, it's automatically collated, everything is collected in one locations. It's a lot easier to use in the field to tap buttons on a screen than it is to write items down on a page. So it's quick, it's easy, and it's effective. Of course, the downside is you're still manually collecting that data. Now, how do we do it? We use this program called Pinpoint, which is we worked with Pinpoint Geotech to put together this program for our inspection. It's a ruggedized Android tablet. Of course, it has to have sunlight visibility so that you can be out in the field doing it. It has to have a long battery life, and the Pinpoint system is connected to the cell network, and it's automatically uploading data. In fact, we can go in and see where our inspectors are at with this system. At any time, we can see where they're at, and if they're at lunch, if they're doing the data collection, where they're doing the data collection. And the advantage of that is, obviously, we know where our inspectors are at, but also if we lose one of the devices, which we did during our inspection, it either got stolen or it bounced out of the bag. We lost it, but we didn't lose the data. So the data is not locked to the machine, so that really helps us keep the data even if something happens to the unit. It also has a camera, so we take pictures. And of course, it has GPS integrated into it, so we know where we're at for mapping purposes. So when we're out there in the field, how do we collect this data using either the manual method or the Pinpoint method with a tablet? Is we use electric bikes. Now, obviously, electric bikes have really come a long way in the last few years, and it saved a lot of legs out there in the field for our guys doing this inspection last summer. And it's obviously a lot easier to use these electric bikes, and they're very mobile. We can use them on sidewalks. They go up and down ramps just fine, and they're not that heavy. So if we come into a crosswalk that doesn't have a ramp, we can lift it up onto the sidewalk. But it's relatively easy to get around, and then the tablet is connected to the bike, and we take it off, and we make the measurements, and we record the measurements, and that is the tablet data collection. So even though we're using the Pinpoint tablet, it is still a complicated process. This is the selection tree for data collection for last summer. We were collecting ramps, we were collecting sidewalks, and we were collecting pedestrian crosswalks. And in the sidewalks, we were even collecting the driveways. So each one of these button pushes opens up a new menu to add the data to the tablet. Can you imagine trying to do this on paper? It would be impossible. So the Pinpoint device really saves us a ton of time and, of course, accuracy for our data by it being in the cloud for us to collect. And then having those pictures and GPS, of course, are an added benefit. This is what the data looks like in the tablet format or table format. It has the latitude, longitude, when you collected it, all of the information. It has the photo, and it even has a link to the map and for the location. So all this information is tabulated automatically, and we don't have to translate it from paper to the computer. So that saves accuracy. So how do we map it? Well, we can map it in a KML, and I'm going to go to it right now, and you can see this is a map of all of the ADA ramps. And in this system, you can pick a ramp, and it will come up with all of the details of that ramp and what is it compliant, is it not compliant, and what those issues were for that ramp. Okay, and this one, the landing counter slope was greater than 2%, the ramp running slope was greater than 8.33%, and the curb slope was greater than 8.33%. So this is a non-compliant ramp, even though this is a very good ramp. It's still technically non-compliant according to the ADA standards. Go back here. The last way to collect data is by using LiDAR, and we're going to attempt to do this for a city this summer using a program called Deep Walk, and it uses the LiDAR on an iPhone to collect an image of the pavement and the ramps, and that information is uploaded to the cloud, and that information is then processed back in the office to get you the slopes, the widths, and tells you if you have to actually tell it whether or not it has truncated domes. I'm sure they've got some sort of an algorithm in there to say yes, their truncated domes are present or not. But the key thing about LiDAR is it is not foolproof, and it is not an ADA compliance inspection. It is going to get close, but they have specifically said it will not provide you a definitive ADA compliance standard for that ramp, whether or not it is compliant or not. So just to quickly recap on how we do the data collection and the comparison of the advantages and disadvantages, the manual method is the easiest thing to do. Obviously, it's the easiest thing to do, easiest thing to train. You don't have any technology, just write things on a page. The disadvantages are obvious. The amount of paper, the time-consuming process, translating the information to the digital system, and of course, no GPS coordinates and no pictures. I didn't even put that on there as a disadvantage. There's no pictures on here either for the manual process. So when you translate and go to the tablet-based inspection, it's going to be faster. It's going to have GPS coordinates, going to have pictures. There's no paper to lose, and the data is automatically uploaded and ready for analysis. So I can tell you each day how many ramps were done and how many were compliant, how many were non-compliant. The disadvantage, of course, is that it requires hardware and software. It's still a manual measurement, still has human input. You could have battery life and device durability issues in the field, though they're not, because they're ruggedized tablets, that's not a very large problem. You have initial training, but again, push button is not that difficult. And you do have, sometimes you have technical issues. We ran into a cell phone tower issue where we had no cell phone connection and the program was locking up on us. So you can still have technical issues with the tablet-based solutions. Now, is it getting better? Sure. And when everyone's connected through their cell phone through Starlink, we'll have no problems with connectivity. But for now, you can have technical issues. And LiDAR. LiDAR is the newest, greatest, best thing, right? It's going to get high precision GPS. It's going to have integrated photos. It's got a 3D point cloud. You don't have to bend over, although I will argue holding that phone like this for 8 hours a day and walking slowly and looking down at your phone is a little bit of a strain. So we're actually investigating using vests of some sort with a phone holder to prevent those fatigue issues with collecting the data this summer. But that definitely can be a fatigue issue. Now, what are the disadvantages? It's not providing full ADA compliant measurements. It's relatively slow. You actually have to walk pretty slow during the inspection to get this point cloud using the current technology in the iPhone. It's very, very expensive to implement. The software is relatively complex. And all of that data is being analyzed back in the office, which is, again, a complex issue. And technology is still evolving, so there may be frequent updates, which anytime you have an iPhone update, something might stop working. So that can be a problem also. But so both or all three types have advantages and disadvantages. Now, how do we tell whether or not a sidewalk is compliant? Well, I have done an inspection where I just looked. I just looked and said, okay, I've got two ramps here. Which one's compliant? Which one's non-compliant? Well, the one on the left here looks pretty compliant. It's got the truncated domes. It's about 3 feet wide. It's got a nice landing at the top and a nice smooth area at the bottom. This one on the right, oh, definitely no truncated domes. The slopes are all off. It's definitely non-compliant. But the only way to know for sure is to measure. Both of these are technically non-compliant. This ramp is too steep, so it is technically non-compliant. Now, we're going to talk about management. Which one am I going to spend my money on to fix? Well, I'm probably going to spend the money on the one that is really non-compliant compared to the one that is only a little bit non-compliant, and that's where the serviceability index comes in. So go through a couple of images here just to gauge everyone's knowledge of ramps. Is this one compliant or non-compliant? Years ago, it was compliant. Now, it is not compliant. There's no truncated domes is the biggest obvious thing that makes it non-compliant, but the landings and the slope, the curb slope here, it's too steep getting up that curb, and so this ramp is technically non-compliant. What about this one? Well, look at what they did here. They retrofitted the truncated domes by putting it down with epoxy on this ramp, and that makes this ramp compliant. If they didn't have these truncated domes, it would be non-compliant. Is this ramp compliant? This one looks great. It's got the concrete truncated domes, which can wear off, but the truncated domes here can wear off, and this whole pad can come off too. But is this one compliant or non-compliant? Looks really good. Technically, this is non-compliant. That cross slope on the landing area is 3.5%, so this is technically non-compliant. What about this one? It's got the turning area, the landing area at the bottom of the ramp. You turn and go up the ramps on either side. This one is compliant. And the final one here is this ramp compliant or non-compliant? Well, this ramp, it looks really great. It's got truncated domes. It's a nice slope. I don't know if it's compliant or not compliant without measuring, but I did measure, and this one is compliant. So that being said, all of these that are non-compliant, all those ramps that are non-compliant, are they still good ramps? They are ramps, and they are functional. They are functional ramps. They are providing access to disabled folks. Which one is the least functional out of all of these? It would be that one on the lower right here that does not have any truncated domes, and the slopes you can tell are off. So that one would be the least compliant. But how do you tell someone that's doing management or asset management that this is the one they should fix and not these others? Well, you need to prioritize based on metrics and manage based on logical use of funds. And so that's where we have to decide how big the problem is. This is what we need to look at to manage our asset. How big is that problem to begin with? And we know it's huge. We know that only 3.7% of these ramps are compliant. So it's a very, very large problem, and we need to do something about it. But we need to figure out how to rate these ramps to tell which ones we're going to work on first. So now that I have a score of this, and I'm going to talk about the serviceability index here in a second, but now that I know I have a ranking of these sidewalk or these ramps, which one should I fix first? Well, the number one thing to figure out where I should fix ramps is, do I have disabled people that need those ramps? If you know of disabled people in an area, then those areas should be the focus. And how do we say, hey, I want to work in this area and not this area? Well, you identify critical locations, locations where disabled folks might be more likely to be, or in this case of schools, where children are that might have mobility issues getting up and down sidewalks. Okay, so you identify these critical locations, and you have grocery stores, post offices, schools, public buildings, hospitals, long-term care facilities. All of these are likely candidates for having disabled people around them that would have mobility or visibility issues or vision issues that they would need these ADA ramps. So you have to prioritize and create these transition plans for those areas and manage those areas so that you can adequately apply funding to get those ADA ramps and accessibility improvements for not just the disabled people, but for the entire public. So the last thing you do is you take all that information and you budget and you fix the ramps that can be fixed. And, you know, again, if you have technical infeasibility, then don't spend money on a ramp that can never be compliant because of the existing grades or the space limitations. Like for this ramp on the left here, there's a space limitation for a landing at the top. So in this case, you would only be able to put a landing down at the bottom, and then have flares going up, ramps going up on either side that meet the ProAg requirement. Okay, but you have to budget and fix those ramps based on prioritization, which is based on identifying critical locations, which is based on rating the ramps, which is based on where the problems are at. So all those things come into play with managing the ADA assets. Okay, now let's get into asset management. How do we manage that problem? We've kind of already hinted at it. The need is the number one thing for managing your ramps. Where is there a need? And that can be based on people, but it can also be based on location. And then the last thing that you can incorporate is this serviceability index that we came up with. Okay, and so what is the serviceability index? I'll give everyone a second to read this identification of the serviceability index. Essentially, it's similar to a PCI, but for ramps. And I normally don't put large paragraphs on my presentations, but I know this presentation is going out, so I wanted the definition in the slides when it goes out, so that if you're reading through the slides, you have a definition, and you're not looking at a picture trying to decide what the ADA ramp serviceability index is. So what do the scores mean? Well, 100, the only time you get 100 is if it's a fully compliant ADA ramp. If that ramp is non-compliant, then it cannot have a 100. And 80 to 99 is a very good ramp. It's functional, but there may be, one or more issues. Maybe there's excessive slope because of the grade in the area. Maybe the detectable warning issues. So the detectable warning strip, instead of being 24 by 24, 24 inches by 24 inches, it's 24 inches by 18 inches because that was the standard previously. Maybe there's a connection gap or a little bit of a bump between the sidewalk and the ramp, but it still provides good accessibility, and it still is functional as a ramp. 50 to 79, now you're talking about a ramp that's got some limitations and is going to cost more to fix. So if we talk about costs, the 80 to 99 range, it may not cost much to fix those, especially if it's a detectable warning issue. You just need to slap down some truncated domes and epoxy down truncated domes. That's an easy fix. Or you have to shave off a lip of some sort. That's an easy fix. But if it's an issue to do with the excessive slope, then nothing you can do is going to improve that. That's what that statement at the bottom is about. Nothing you can do is going to improve the serviceability index if it's technically infeasible to make it compliant or to improve slopes or to improve space. Okay, back to 50 to 79. It's fair, it's usable, but has some limitations. So it's kind of okay. Now we get down to the 25 to 49 range. It is not a good ramp. Maybe kids, teenagers and adults can use it for their bikes, but it's poor for strollers. It's poor for people with visibility issues. It's poor for those in a wheelchair. It has some major issues. And then 1 to 24. Now this one, all you can say is there's a ramp, and that is not a good thing. It's hard to use. It's not safe. Someone on a mountain bike could use it, and it's better than going up a vertical curve. But that's about all you can say about it. And if it's 0, then it's missing, or it's cracked in half, or there's a big pothole in the middle of it. That would be a 0. So now, how do we look at and calculate that ADA compliance, that serviceability index? Well, the two that are 100s here look great. They've got the truncated domes, good slopes, good flares, good space on top and bottom. These are great ramps. Now we're going to talk about sidewalks. I put these pictures in here for a purpose. You can see there used to be some sort of a pole here, and it got knocked over. Well, there's an obstruction. And you look at this sidewalk up in the upper right, and now this sidewalk has obstructions. The clear space for a sidewalk is 3 feet. And even though you've got a great ramp, the sidewalks don't work because there's obstructions on the sidewalks. So not only do you need to look at ADA ramps, but you need to incorporate sidewalk use also. And I'll talk about sidewalks at the end here. But these ramps are considered 100s. Now, looking at two other ramps, the one on the left is a 98.2. Why is it a 98.2? Well, it's got a lip at the bottom that's more than a 1/4 inch. So that lip at the bottom makes it non-compliant, but it's a darn good ramp. It's a 98.2. So all I need to do is go in there and shave off this the lip, and now I'll have a compliant ramp. So that's great. This one on the right is 32.2. It's got faulting. It doesn't have truncated domes. The slopes are too steep. It doesn't have a landing at the top. The bottom is questionable whether or not it has a space to turn around. So definitely a very poor ramp. But again, it's functional, but this one is dangerous because if you're sitting on this ramp, you're going to roll into the street. So it definitely is a dangerous and unusable ramp for most people that have disabilities. So what we do for calculating the serviceability index is we put all of the data into a spreadsheet based on all the different categories of compliance, and all of the red are the items that are non-compliant. These are non-compliant items, and if any of these are non-compliant, then this column over on the right here is non-compliant. So anything missing makes it non-compliant. Now, that doesn't mean it's bad. Like I said, you want to put a count or a code to that serviceability, and that's where the serviceability index comes in. We essentially are using a similar deduct to a PCI score with a higher deduct for critical parameters. Just like potholes for a PCI destroy the PCI, well, ramp slope and ramp width are the two critical parameters and have the highest deduct if those are not met. And it's a graduated deduction. So if this is a counter slope at 3% is not as bad as a counter slope at 5%, for example. So we have a deduct, a weighted deduct based on how bad those values are. Now, of course, if there's no truncated domes, that's a yes or no. So that is a simple calculation. But you know, the slopes, they are all graduated for how much they reduce that serviceability index. And I'm not going to get into the calculation here, but it's simply a spreadsheet, and we use a weighted calculation on deductions to give the serviceability index. How do we map the serviceability index? Well, we do it the same way that we mapped all of the ramps. We can apply a code or put the serviceability index and then give a red, green, and yellow based on the category. In this case, I gave red, green, and yellow to serviceability indexes of greater than 75 are green, 45 to 75 are yellow, and greater than or less than 45 is red. So let's take a look at some of these. Let's see if we can look and see why this one is bad. So this one has a 31.6. Why? Because it's got a lip, because these slopes are bad, and because the slopes on the ramp are bad, no truncated domes, all those come into play to say this is not a very good ramp, that something needs to be fixed. And in this case, it looks like these slopes going into the ramp need to be adjusted because it's really hard to get up over that lip when you're coming in at a sharp angle. And those that have a higher score, those are going to have less non-compliance. So the truncated domes aren't present, but it's got good slopes and it can be used, and it's got a smooth transition. You can see there's no lip at the bottom there. So that one is an 82.5. So that isn't a bad one. So that's how you can visualize where, and it's pretty obvious that there's an area in the city here where the ramps are not very good. So this may be an older section of the city, and maybe you need to spend a little bit more time focused on that area for managing your ramps. In the end, ADA compliance is non-negotiable. We have to do it. The serviceability index is going to allow us to manage that asset instead of just doing ad hoc, someone's complaining, fix it kind of management. As we know with PCI, that is not the most effective use of your dollars. And in the end, we want to use the funding to improve that accessibility for the greatest benefit to the entire community. So that's why we're talking about this serviceability index and managing the ADA ramp problem. So at the end here, let's talk about sidewalks. Getting close to the end here, we're on to sidewalk inspections. How do we inspect our sidewalks? Well, it's a little bit easier than ADA ramps. There are not a lot of specifications on sidewalk qualities or sidewalk conditions. There's ADA compliance. The sidewalk has to be 3 feet wide. It has to be unblocked by an obstruction. And if you have an obstruction, you have to have a butt out, if essentially, and I'll talk about that in a second. But in reality, we've been basing the condition on this subjective, good, fair, very poor kind of a process of, and I've got some standards here I'll show you in a second, but it's very subjective. So we would like to eventually go on to more of an objective measurement for sidewalks. The problem is sidewalk sections can be 20 feet long or they can be 200 feet long. So we run into the same kind of sampling problem that we have with PCI on sidewalks on determining that condition. So we're working through that and we will get there for a sidewalk evaluation. But for now, it's good, fair, poor, and very poor, and where you need emergency repairs. And I'll show you those in a minute. But essentially, you're trying to make sure that that sidewalk is usable for anybody to use safely and provide routes from point to point safely. So sidewalks generally have 4 primary challenges. Number 1 is missing any curb ramps at intersections or transition points into the road. The second one is you have obstacles, and obviously you can see these telephone poles are running all the way down this sidewalk. They're right at the right-of-way, and it is very hard to make this sidewalk compliant for ADA based on where these posts are. So obstacles are a huge issue. And then you have surface problems. This is a 5-inch drop. They actually put concrete in here, not even asphalt. They poured concrete in here to try to make that a smooth transition. But that is not a good repair. That is definitely a problem. That sidewalk is in poor condition because of that huge bump and that fault that you have to climb up when you're walking. So that's a definite tripping hazard there. The other thing is that you have cracking, and the cracking obviously is not a smooth surface for people to walk along. So anyone with mobility issues or sight issues could trip on these cracks. And then, of course, these cracks are also going to confuse folks that are using a cane to travel, where they might think they're coming up to a ramp or they might be coming up to a road, so it can be confusing. And then the last thing is that there is no sidewalk. In this case, you can see this beaten down dirt path here, and even on my own street where I live, that my son goes to school up the street, there's no sidewalk, which is a huge issue because next to schools, you probably should have sidewalks so kids can walk to school safely and not be in traffic. So that's a huge issue. So how do we rate them? Well, we kind of have a general idea of what good, fair, poor, and very poor mean, and what where an emergency repair is needed. So good, not much of a tripping hazard. Again, that 1/4 inch threshold for a tripping hazard. Fair, yeah, even a 1 inch fault is going to be a pretty big fault for tripping. Poor is where you have a really big fault, and then very poor is like that picture here where you have a 5-inch fault to climb up, essentially climb up and to use that sidewalk. And then how do you say the entire section of sidewalk is bad? Well, if it's just one panel, then it's not too bad, but you need to record that panel needs to be fixed. If it's a lot of panels, then it gets worse as you go down for the amount of panels that are cracked and spalled. So we do need some sort of a serviceability index, and we're working on that for it's under construction, but there are ways out there to evaluate sidewalks, but there are a lot of ways. And so we're going through all those to try to find the best way to provide an objective evaluation for our sidewalks. And then how do we visualize? Again, we can map all of the sidewalk conditions. And in this case, we did the same thing with the tripping hazard. Again, this is using the pinpoint software. So anywhere you can see the tripping hazards around the city, and we supplied these to the city. So there's hundreds of tripping hazards, and they've done a pretty good job. You can see some of these that they've been out there and they've actually done and tried to repair these tripping hazards. They'll throw asphalt into it, right, and make it nice and smooth. Well, it's still technically a tripping hazard because there's a transition, an elevation change. Anytime you have an elevation change, that is a tripping hazard. Now, but like I said, not a lot of these are out there as actual tripping hazards. A lot of these are minor tripping hazards where you have faults and they just need to get repaired. Well, a good repair again is expensive, and then who's responsible for doing that repair? All of those come into play with deciding to fix those sidewalks. And again, a lot of the time they just put some asphalt or maybe pour a little bit of a concrete chunk to make that tripping hazard less. It's still a tripping hazard, but maybe make it a little bit less. So that pretty much concludes the presentation. Just to wrap it up, what we're talking about, ADA ramps are great for everybody, not just disabled individuals. The compliance inspections are very time-consuming and complicated. You are not required to reconstruct, but you are required to be proactive and manage that problem. And the best way to do that is figure out where the disabled individuals have a need, figure out the location for pedestrians, all pedestrians, and then use our serviceability index to help prioritize where repairs and reconstruction need to happen. And then, sidewalk inspections are also very time consuming. You have to be on the sidewalk. I didn't mention that. You can use LiDAR also for sidewalks, but you can't really use a vehicle-based sidewalk inspection because there are parked cars, there are trees, everything obstructing the visibility of that sidewalk from the road. So you still gotta kind of walk the sidewalk or ride on the sidewalk to do that sidewalk inspection. And you should have an objective scoring system for both the ADA ramps and for the sidewalks to properly manage that problem. And it is a big problem. And so now I'll transfer back. Thank you. That concludes my presentation. And then I'll hand it back over to Shri.
Thank you very much, Phil. That was very informative, and I certainly learned a lot from your presentation. Those of you who are attending the webinar, you may begin submitting your questions in the chat box, and Phil will answer as many questions as possible in the time that we have remaining. Just wanted to talk a little bit about our upcoming webinars. We hope you enjoyed today's presentation and that you will join ARA for future webinars. On April 9th, Dr. Abu Sufyan and Dr. Ted Argo will talk about possibilities of quiet pavements in reducing road traffic noise. And then in May, on May 21st, Dr. Hannah Silber and Neil James will present Expanding the Horizon for Asset Management, TAM, Transportation Asset Management, Beyond Bridge and Pavement Assets. So two really interesting and diverse topics coming up in April and May, and I hope you can join us for that. We have many more exciting topics in the works, so please watch your email for updates or visit the Webinar Wednesday webpage, www.ara.com/webinars to get on our mailing list and register for these webinars. Next slide, please. Phil, we have a bunch of Q&A questions, and I'll kind of try to go through them and moderate them as best I can. Some of these have to do more with the standards themselves, and I don't know if you can answer them, but I will ask them and you can provide your response to that. Barbara wants to know if wheelchair turning radius is 67 inches or 60 inches. Why is the clear space at top and bottom only 48 inches?
Great question. And no, I don't know the answer to that one, but I can speculate. I can speculate that ProAg has been in the works for 35 years and that they came up with a reasonable number to get to the standard. I mean, literally, they've gone through iteration after iteration. So, but I don't know for sure why, ADA turning radius is different for, construction, building construction than it is for the ADA ramps. But it is a 4x4 is the space for the landing.
Jason wants to know, are the slope percentages from absolute level or based off of curb or road elevation?
Great question. Absolute level. And that's why a lot of them, it's technically infeasible to meet that slope. That is a huge factor. It is absolute level because no matter if you're on a hill or not, you're still going to roll down And so, but again, that's where the exemption comes in, and you have to apply for that based on technical infeasibility, and you do the best you can. And in fact, I just saw this. It's just so funny. I was just at Walmart 2 days ago, and they had to essentially put up railings because of a drop off at the ramp. And they're new. They're relatively new. They weren't there last time I went a few months ago. So, they had to do something because it was technically infeasible for them to make that ramp totally ADA compliant. Good question.
Thank you, Phil. But there was a comment or a question online from Chris when you mentioned the LiDAR detection. Can you strap the phone to a Segway or some other mobile device while doing the LiDAR survey?
Yeah, whatever you can strap it to, whether it's a person or a bike. The key thing is the speed of data collection and where that device is at. So yes, you could put it on a Segway and you could put it on a bike, but it's got to be level and it's got to go very slow. It's a very slow process. At the moment, again, technology is improving, so maybe that gets better, but I've actually played with it a little bit in my office, and you have to go slowly to collect that LiDAR data, to collect that point cloud. Can you imagine? I mean, it's a point cloud, and anyone who's dealt with LiDAR knows how much data that is. So there is a huge data issue, data storage, data amount, data transfer issue with the LiDAR system. Thank you.
There's a question on drainage. Are there any drainage requirements included? Often we see gutters to ramps sitting in inches of water, and it's very difficult to those who use walkers or have sight impairment if there is any water near the ramps.
Great question. And because everything is very level, it's going to hold water, right? So I don't know the exact answer for drainage requirements. All I know is that the ADA requirements for ramps are the requirements that are shown. And if that causes a drainage problem, that is a secondary issue that needs to be addressed. Absolutely needs to be addressed. But how do you do that when the whole road, especially, I've seen this in Florida, where everything is flat and the whole road is underwater. So that happens too. When there is no drainage, you're right, it's going to pond. And we actually recorded a few of those when we did our inspection where the ramp was, the bottom of the ramp was underwater. So definitely something that needs to be considered. It is not in the ADA ramp compliance standard.
Thank you, Phil, for that answer. This may be a little premature, but I want to ask you this question. Lisa wants to know, is there a publicly available map that shows the ARSI rating for ramps that would enable people with disabilities or bicyclists to choose a route based on accessibility?
No, the ARSI is brand new and is not publicly available. And most likely it goes to the city. If the city wants to publish it, they can publish it and produce a map. But that's definitely a city's obligation to publicize that.
All right, thank you, Phil. There's a comment or question from Robert. You referred to PCI a few times. What is the meaning of PCI?
Oh, sorry, the PCI is the pavement condition index. So we rate the pavements based on the distresses in the pavement in the road, and so the serviceability index for ramps is not the same. The PCI goes from 0 to 100, also 0 being the worst, 100 being the best. So it's just a different asset management tool essentially for pavements.
Thank you, Phil, for that clarification. Jason wants to know, is there a maximum cross slope for sidewalks to conform to ADA?
Yes, 2%.
Thank you. Becky wants to know, do federal government regulations mandate ramps be made fully compliant when federal highway funds are used to perform roadway work adjacent to ramps and sidewalks?
Great question. And since the DOT just adopted the standard, I don't know the exact answer to that. I would imagine yes. And in fact, I know that in California, anytime they build a road, whether it's in the middle of nowhere or not, this is what we did for the city that we were working with. They actually have ramps at intersections in the middle of nowhere where there is future planning for construction for residential areas. They were required to put those ramps in because they were reconstructing the road. So most likely there's going to be a requirement to rebuild the ramps if they're non-compliant.
I think Greg has a similar question, and I don't know if I fully understand it, but I'm going to read it out. When doing a rehabilitation road project and addressing non-compliance ramps, are you required to upgrade the ramp if you can make an improvement, however, will still be non-compliant? So I guess if I'm interpreting that question correctly, do you have to upgrade the ramp to where it is fully compliant?
Yes, you can't do a half solution. So when you're managing your ramps, like we discussed, if you're managing your ramps and all that is wrong with that ramps is it's missing the truncated domes or it's missing or there's a lip, you can manage those ramps and add those two items and improve the ARSI even if it doesn't get full compliance. When you're managing, if you have reconstruction, the reconstruction mandates that it be a fully ADA compliant ramp if it's technically feasible. If it's technically infeasible, then you can get a waiver that says it's technically infeasible to do this, and therefore it does not have to be full ADA compliance.
Thank you, Phil. Aaron wants to know, when is ProWag going to be officially adopted? Do you currently consider something ADA compliant if it meets the 2010 federal specifications?
Great question. ProWag was implemented by the Department of Transportation on January 17th of this year. The Department of Justice has not adopted it, and there is no schedule for adoption by the DOJ. They're looking at it, but they're not saying we are going to accept this or not quite yet. So, I mean, of course, they're looking at the legal ramifications. The DOT is looking at from a practical accessibility and reality situation, whereas, of course, the Department of Justice is looking at who's going to get sued. So there is a disconnect there, and I don't know when the DOJ is gonna say this has to be compliant.
Thank you, Phil, for that answer. Rob is getting into a little bit into the details, so I'm going to ask Rob's question. The ramp width and slope has the higher weight in the calculation. What percent would you say it is? 25%, 50%?
Well, yeah, that's about right. That's about right. It's about 20 for both of those. It's about 35 to 40% is the ramp slope and the width are in the RSI. But we are actually still adjusting those factors as we get this kind of rolling, and we're talking with the cities and we're talking with disabled folks on what the priorities are for each of the different elements of the ramp. So it will be adjusted as we move forward. It is not a fully accepted term or number yet, but we're getting there and we're in the process. So we'll but again, we don't want to, this is ARA developed, so we're keeping it within ARA.
There's a comment in the chat about the turning radius, and maybe this kind of answers the question. Ron suggests that 48 inches is the minimum radius a wheelchair can turn for ProWag standard. So,
got it.
Let me see. I think there's more questions here. Barbara also wants to know, how often are you asked to check pedestrian need? People move and building use changes. So can you address if things change, do you look at your pedestrian need again?
Great question. And that is a city requirement to address their community. And they can do a survey every year. They can do a survey every 5 years. It is totally based on what the city decides for an accessibility survey to see where ramps are needed or where accessibility needs to be improved. So it's not mandated by ProWag. That's a management process for the city to take care of.
There's a couple of comments on ProWag itself, and I think there's a comment that Says PROAG was approved July 3rd, 2024.
It was not implemented until January 17th, like fully accepted for implementation. There was a transition period from last July till January.
Okay, thank you. There's another question that says sidewalks, and this is going to be the last question, Phil. We have a lot of questions. People are really interested in your talk, but this is the last question, and then we'll kind of wrap up the webinar. This question says sidewalks are 3 feet. Is this going to increase? A powered chair can take up most of that and run the risk of falling off when poor conditions exist.
Sure. And I think you just figured out why it took 35 years to get it implemented, because the goalposts are constantly moving. There was no requirement for truncated domes years ago. Why did they change the truncated domes? Well, because they used grooved lines, and the grooved lines can be confused with sidewalk conditions, and so they went to truncated domes. So I would say that this is a living document, but based on how long it took to make the original, and get it implemented, I don't know that there's any changes coming anytime soon. But definitely larger, power chairs, and even if you're in a wheelchair, that's going to block the sidewalk. So definitely, it's a living document. It probably will change at some point in the future as technology changes, or as they may realize that, hey, these truncated domes, this isn't the best solution because they only last 5 years and we got to keep replacing these things. And so we got to do something else. And, so I would say that it is a living document that will probably change in the future.
Well, Phil, thank you very much for your answer and for your answers and your presentation. We just have a few more minutes, and for those of you who are attending the webinar, if we did not get to your question, or if you have any follow-up questions, Phil has agreed to answer questions for the next 24 hours via email. His email address is shown on the screen, pdonovan@ara.com. And we just ask that you make sure that your questions are not of the consulting nature and kind of limited to some general knowledge questions. And of course, if you have anything you want to follow up with Phil on, he'll certainly answer your questions. On behalf of ARA, I really appreciate all of you joining us today. Next slide, please. Today's presentation is being recorded, and a link will be made available on the ARA Webinar Wednesday website sometime next week. And we will also send a PDA certificate to all participants verified by our attendance report as present for the full hour of the webinar. A copy of today's presentation will also be included in that email. Please allow about 3 weeks or so to receive your certificate and a PDF of the presentation. Next slide, please. ARA is a great company to work for and really very unique in that it is 100% employee owned. We continue to grow dynamically and are always looking for great people to join our team. If you are interested in employment opportunities with ARA's transportation and infrastructure offices, please send a resume and contact information to the email address shown in your screen. That's www.joinara@ara.com. Webinar Wednesday, joinara@ara.com. Again, thank you very much for joining today, and we hope you will join us on April 9th for our next Webinar Wednesday, possibilities of quiet pavements in reducing road traffic noise. So that'll be a really good presentation as well. And really have a great rest of the afternoon and rest of the week. Thank you very much. Bye-bye.